In this video, we're going to talk about some common mistakes with loops and how you can avoid them. So let's just say I was going to make a loop that was going to print out numbers from 0 to 10. And I'm going to go ahead and print out each of those I values. So looks good. Well, it doesn't like I. Well, I don't know why that is. I'll change it to A. I'll print out A's. That sounds better. And I run it, and it print out 1A. What the heck? Why is that? Well, it goes back to why this was an error from before, and Java's like, there's no variable I. And you're like, what? But I made a variable I. I mean, the only way that could happen is if I was doing something after the loop. And the fact is you are doing something after the loop because this loop ends right at this semicolon. This guy right here is bad. That means that this loop will run 10 times and do nothing, and then this block will print out whatever is supposed to be in this printout statement, which doesn't exist. Do not put semicolons at the end of loops. It's bad. See, that works. So a related issue to that is when you write a while loop. So I'll make my variable here, hopefully on the previous line, while I is less than equal to 10. I'll put the mistake semicolon there, do I plus plus, and do a print out of I. And so I'm expecting this to do a whole bunch of printing, but when I run it, it does a whole bunch of nothing. Because this while loop now keeps checking if I is less than equal to 10, and if it goes back and checks if I is less than equal to 10, and if it is, it doesn't do the loop body because this isn't part of the body because we put a semicolon. Don't put semicolons at the end of loops. It's bad. Okay, so that's the first thing. Don't do that. No semicolons at the end of loops. The next issue that can come up is if you're having issues with your braces. So let's say you're doing this, and then inside your loop, you are going to print out what I is, and then on the next line, I'm going to print out or increase I by 1, because I want this to stop eventually. If I don't increase I, it'll never stop. So I'm going to run it, and oh my god, it's printing out all these ones. It won't stop. Why won't it stop? Well, that's because this I++ is not in the loop body. If I want that I to plus plus to be in the loop body, I need curly braces. Now if I run it, it will stop. See, it stopped. So anytime you're writing a loop, I think it's a good idea to have curly braces. That way you can clearly indicate what are the statements you are repeating. All right, next thing, and this is a small problem, but it happens every once in a while. Let's say you have a Boolean variable called done, which is set, well actually let's say not done, and say that is equal to true. And then you're trying to be clever here, and you want to write in the loop, while you are not done. So while that's what you mean to write, but then you forget one of these equals here. And then the statement here, you would like to print out like a random number. So I'm going to generate a random number, int math.random times 5. And then I'm going to print out the random number on separate lines. And then if that random number turns out to be 0, then I will set not done to be false, because it's not that I'm not done anymore. Found 0, so I am done. Yay! Code, it'll work. Except for this will run forever. And you're like, what? How can this be true? Because if you watch, and let's see if I'll stop it here, you'll see there's, oh, I can't see it. Where's the 0? There's a 0. Well, if 0's been run into, then not done should be set to false, so this loop should stop. The problem is this is an assignment statement, not a comparison. You need two equals. If we do this now, it'll stop. See, hit 0 and it stopped. Wonderful. So if you are ever comparing a Boolean with a true or false value, write equals equals, or do this instead. Much better. Don't compare it at all to an equals because it's true or false to begin with. Now if I run it, see, once again, stops wonderfully. So watch out when you're using two equals to do a comparison. Some other issues that can come up which are a little bit, they happen a lot. So let's say I'm going to do this loop here, row less than equal to 4, row plus plus, and for int column equal to 0, column less than equal to 3, column plus plus. And I'm going to introduce an accumulator variable. So the first place you could introduce an accumulator variable is right here. And then I could increase the accumulator by, I'm going to do it by the column position. And then I'm going to print out sum. And this code works fine. If I run it, it does something silly, but it works. And actually, you're like, okay, it's just printing out 0, 1, 2, 3. I thought I was accumulating. Well, the problem is, in this loop here, it keeps recreating the sum variable each time. So this is like Dory from Finding Nemo. Every time through this loop, it forgets the old sum value, sets it to 0, and increases it by the column. So that's bad. So we're like, okay, so I want to print out this sum after it's done adding up everything in that column, or in that row, sorry, in that row. And then you get this error here. And the issue is the sum variable is declared within this for loop. So that means you cannot use it after the for loop. So if I'd like to actually print out this sum, I need to put the sum variable right here. So I create an accumulator, then I'm going to increase it by each of these column positions from 0 to 3, and then I'll print out the sum afterwards. So now if I run it, that's a little bit scary, but that is because I've added up the numbers 0, 1, 2, 3, and I printed that out, and I've done that a total of 5 times, because this outside loop runs 5 times. Now, some interesting things, if I were going to move this print statement below this for loop to here, once again, that would be an error. So I can't do that. I could move the sum variable up here, which is interesting, because now if I run it, you'll be able to get the numbers 6, 12, 18, 24, and 30. That's because I now have a sum variable that applies for the entire problem, not for an individual row. If I then move the sum variable, or the print statement, all the way outside the loop, it's going to print out one number, which is just going to be the total sum. So placement of variables are very important when you're using nested loops. You have to worry about scoping rules. If I move this sum variable inside of this loop, I'm not going to be able to use it outside. So be aware of that. Another issue that can come into play is more when you have a separate method that you're calling. Oops, I always do that. And I'll just do the example we've done before called isPrime. And we'd like to know if a number is prime or not. And so our strategy was first to say any number that is less than 2 is not a prime. And then we're going to start a loop here. So for int I equal to 2, I less than n, I plus plus, if it's true that n is divisible by I, then we are going to return false, because it's not a prime. And then what a lot of students make as a mistake is they write an else case here, and they say return true. There are two problems here. The first problem is that Java looks at this code and goes, wait, I don't know that something's going to be returned. Java's not like smart enough to figure out if your logic makes sense. It doesn't look at these conditions and go, yeah, it's definitely going to return something. What Java thinks is, okay, let's say this if case is not true. Okay, it doesn't do that. Let's say this for loop condition is not true to start, so it doesn't do this. So Java thinks it's possible this code will not execute anything, which is bad because it needs to return something. So one good idea is always at the end to return something, and then that error will go away. So always remember at the end of a loop, or sorry, end of a method that has a return statement, it's a good idea to return something. The second issue we're going to have, and I will demonstrate this by actually executing the code, is I'm going to run the isPrime method and print out its result right away. IsPrime. And let's see what number. Let's say I wanted to put in the number 9. Now 9 is not a prime number. So if I run it though, it's going to say it is. And you're like, what? How can that be? Well, what's happening here is when it goes into this loop, 2 is less than 9, great. 9% 2 is not 0, it's 1. So it hits the else case, it returns true, and it stops. And like it says, that's the answer. It says, goodbye, thanks for playing, for loop's done. Which is not what we really wanted to do. We don't want to say if any individual number doesn't divide 9, then it's prime. We want to say if none of them divide it, then it's prime. So we can't write this else case. You don't do it. we don't have information at that point. That the fact that I does not divide n does not tell us that n is prime. It just says that n might be prime. We need the loop to keep running. We can only return true after the loop is done. And now it's saying false, like it's supposed to, because we allowed the loop to keep running. So a couple things that we looked in this methods example here is make sure you're returning something at the end of the loop. It's actually a lot of people think that's a good idea to only have one return statement at the end. I'm not, that big into it, but yeah, if you make sure you have a return statement at the end, that usually will fix errors you're having with missing return statements. And the second thing is if you're writing a loop, and in the loop you write an if-else, and both of them return something, you have done something wrong. There's almost no situation where that's the right thing to do. So lots of errors that hopefully you can avoid. Don't put semicolons at the end of a loop. Don't forget to have your curly braces. Don't use 1 equals when you're doing a comparison. Make sure you use 2. Watch out for scoping issues, and then the issues we just talked about with methods. So hopefully after watching this video, you will not make any mistakes when you're writing your loops.